What this formula does is to tell you the velocity at point B, velocity at point F, velocity at point E, velocity at point A, at point P, at point any point as the body is going this way. That formula, which I call the general formula, is capable of telling you the detail of the velocity on the movement as the body is undergoing simple harmonic motion. But this formula cannot give you the velocity at C, at P, at A, at F, at E, at F, at B. It cannot. And most times when questions come, students are confused. Which one should I use this formula or should I use this formula? And that is why I have come to clear those confusion. Welcome to VINDAL'S Academy. In today's class, I want to talk about simple harmonic motion. But before the end of this lesson, you are going to understand how to use these two formulas and why it is very important to only consider this formula and ignore this if you're a beginner. And this video is centered on why you don't understand physics. And let me talk about that briefly before we go to the lesson. And before I continue, I also want to let you know I'm going to explain this using the principle of simple pendulum. Now, if you're a student, this is the best lesson you have to learn, like, comment, and share. Any area you do not understand, you comment and I will be responding very fast. And also, if you're a teacher, I know how it was when I was starting. And I'm also going to tell you how best to use this to present to your students. If you are ready, please, like I said, don't forget to hit the subscribe button, like this video, and share it. For YouTube algorithm to be able to share our content, because I tell you, this is one of the best contents you see on YouTube. All right. First of all, the question is, what is simple harmonic motion? You see, simple harmonic motion, I'm going to be posting some videos for you to see. Any object that undertakes this kind of motion, this one, and this one, they are called simple harmonic motion. And as you are watching the video, you see the kind of motion they are displaying. Some are up and down, some are to and fro, some are vibrating. These are called simple harmonic motion. But simple harmonic motion is a kind of harmonic oscillator. What do I mean? What I'm saying is this. Harmonic oscillators are to and fro motion and any kind of motion that undergo oscillation or vibratory. But when they are simple in nature, they are going to have two major concepts that makes them to be called simple harmonic motion. And they are defined, and those two conditions are found in the definition. So what is simple harmonic motion? Simple harmonic motion is defined as the motion, the to and fro motion, vibratory or up and down motion, or oscillatory motion of a body on a straight line, such that, that is the point, such that its acceleration is directly proportional to its displacement. Number one condition that makes it simple harmonic motion is this, that acceleration is directly proportional to what? Its displacement. I'm going to be telling you what displacement is in this case. And also, that is the first condition. Second condition is that the acceleration is directed towards the fixed point. Towards the fixed point. So when the acceleration of a body is directly proportional to its displacement, and that the same acceleration is directed towards the fixed point, and such a body is simple harmonic motion. And such a body is doing to and fro motion, up and down, vibratory or oscillatory, then we say they are what? Simple harmonic motion. So the major condition, that is what I mean by why you do not understand physics. In this definition, there are three major conditions you must know. One is that it is to and fro motion. Number two, that acceleration is directed towards the acceleration is directly proportional to the displacement, and that it is directed towards the fixed point. I think I've made that statement many times in this video. Now, let me explain. If this is the simple harmonic motion or simple pendulum, as the video you are watching, I am going to use Cartesian plane. That means y-axis. Let me call this place y, and let me call this place, this is y as well. This is y, negative y. And this line is my x, or I can call it r. Okay, if I'm using x, I have to use this place as my x. So I'm using x, all right? Now, this is the resting position, which we call the origin, where the body is not oscillating. Now, if I move this body this way, look at what I mean. If I pull this body this way, this is where I stopped. So at this point, let me mark this point. This is the stopping place. So from this origin to this place is called maximum displacement. That is given as x. Now, but this from here to here can be broken down into different numbers. So we can say 1, 2, and let me say 3. So I am assuming that my amplitude or maximum displacement is given as 3. So I'm going to say that x is equal to 3 cm, and which is what? Max displacement. That condition is very important for us to continue. All right, if that is done, if that is the condition, then let me also consider that, because the thing is to and fro, so let me also go to this side. This is going to be -1, -2, and this is going to be -3. Because whatever happens from this to this point is same thing that is going to happen from here to this side. Because it is a force, it has to balance. Now, I'm going to also name these 3 positions. So I'll call this place point A. I'll call this place point B. Let's say point B, which is also the same thing. And this is point C. All right. So I'm going to call this place F. I'm going to call this place E. I'm going to call this place, let me call it P. These are different points. I will tell you why I need them. Now that we have established this diagram, and I want to explain how this system works. This is the reason I told you this formula is not good when you are solving questions under simple harmonic motion. However, this formula is called the maximum velocity of a body on a body undergoing vibratory motion, simple harmonic oscillator. Why this formula, I can call it as general formula. Because what this formula does is to tell you the velocity at point B, velocity at point F, velocity at point E, velocity at point A, at point P, at any point as the body is going this way. That formula, which I call the general formula, is capable of telling you the detail of the velocity on the movement as the body is undergoing simple harmonic motion. But this formula cannot give you the velocity at C, at P, at A, at F, at E, at F, at B. It cannot. And most times when questions come, students are confused. Which one should I use this formula or should I use this formula? And that is why I have come to clear those confusion. So clearing those confusion is I'm going to prove the velocity at B, at F, at E, and at A using this formula to prove that it is the right formula you need and not this one. However, this one can only give you the velocity at one point, and that is at point A. But this one can give you the velocity at all the points along this way. Okay, you're welcome. Because of the length of the video, I have to do this before I continue. Now, like I was saying, if you check the velocity at B, I use this formula whereby I say that my omega or angular frequency is given as 2 radians per second, which I used to put here. And this 3 is always x, which is the maximum displacement on the horizontal axis. and y can take up any number between 3, 2, 1, 0, minus 1, minus 2, minus 3. So y can take any of those numbers depending on the point of the velocity you want to calculate. But x must surely be 3. Now, so at b, I have 3 square minus 3 square, whereby y is 3. So 3 square minus 3 square is 0. 0 times root 2 is going to be 0. Everything has gone. So the velocity at b is going to be 0. And that means kinetic energy at b must be 0. If you check your textbook, the kinetic energy at the maximum displacement is 0. But potential energy is maximum at that point. So let's check what will be the velocity of this body at f. Now at f, I choose 2 to be my y. So this y is 2. I will now put my angular frequency or angular velocity, 9 square minus 2 square. So 9 minus 4 is 5. So 2 root 5 is something as 4.7 meters. So what happened? The velocity at b was 0. The velocity at f has increased from 0 to 4.47. So what is velocity at e? Now, if you do the same thing, velocity at e is going to be 2 3 square minus y, because at e, y is 1. So 9 minus 1 is 8. 2 root 8 is going to be 5.66. So at this point now, velocity is still increasing. Now, when the velocity gets to at a, what is a? At a, this is what happened. The velocity becomes what? 6, which is highest. Because the velocity at this point, if I call this place at q, let's find what will happen, because it started from 0, keep on increasing, keep on increasing. When it gets to a, it becomes maximum velocity. And that is the only place this formula comes. That is why they were always given as V max, which is the maximum velocity. But apart from that, that formula is useless at every other point on the system of simple pendulum. Not just simple pendulum, for any simple harmonic oscillator. As the equilibrium point, final velocity is maximum. Now let me check at q what will happen. So at q, vq is going to be 2 this. At this point, 3, x is still 3, so 3 squared, minus y at that point is what? Minus 1, so it's going to be minus 1 all squared. All right? So this is going to be, vq is going to be 2 root, this is 3, 9, this is minus 1 square is still 1. So what are we going to have? 2 root 8, which is same thing as this, 5.66 meters per second. So you see, velocity at this point, this is at maximum, which is at point A. It will start reducing, reducing, reducing. When it gets to this point, kinetic energy is still going to be 0, because velocity at that point is 0. So at this point, which is the origin, okay, at this point, which is origin, kinetic energy is still going to be what? Maximum, but potential energy at that point is what? 0. So this is the proof of the fact that this formula is the only formula you need, and why this formula is not the formula needed for this one. And I'm going to prove it with a question I am going to solve in this video. Stay put. Don't forget to hit the subscribe button, like this video, and share it. Okay, you're welcome again to VINDAL'S Academy, and this is the follow-up to the explanation I gave you that this formula is not the right formula to be used while solving for linear velocity of a body undergoing simple harmonic motion. So let's look at this question from GCE 2012 or 2022. All right, 2012. It says that a body moves in a simple harmonic motion between 2 points, 20 meters, on the straight line joining the points. If the angular frequency or angular velocity omega is 5 radians per second, calculate its speed when it is 6 meters from the center of the motion. So I am going to interpret this. This is principle based. Based on the principle you had studied, you are going to explain it. See what I'm going to do. What I will do is, first of all, from the question, a body moves in a simple harmonic motion 2 points 20 meters on a straight line. So from this is the 2 point, I'll call point A, I'll call it point B. So it has moved from here to this point is 20 meters. So between the first point and the second point, remember, the body is going to go this way. 1, 2. So between where it was let go and where it reaches maximum height, comes back, is 20 meters in distance. That simply means that this place is going to be from here to the end is going to be 10. That means from here, which is the center, is half of the 20. Because from here is 10, then from here to another place is also 10 meters on the other side. So see the next thing they said. They said, if the angular velocity is 5, calculate its speed when it is 6 meters from the center of oscillation. This is the center of oscillation. 6 meters from, so 6 meters means, let me call this place to be 6 meters. So at this point, let me call this place point F. What is the velocity at that point? Remember, for you to understand this, you need to study what I explained in my first video on simple harmonic motion. So what do? I can never use this formula because it's not what it's talking about. This is the general formula, which is the formula for all of them. So I'm going to say that V is equal to omega is 5. Now, what is maximum displacement? From here, from the center of oscillation to the highest place is called maximum displacement. And what is it? 10 minus 6 squared. So this is going to be 500 minus 36. It's going to be 64, which is 5, or which is 5 times 8, which is what? 40 meters per second. So the velocity, its speed when it is 6 meters from the center of motion is what? 40 meters per second. This is the principle that guides the solution of simple harmonic motion. Don't forget to hit the subscribe button, like this video and share so that at least YouTube can see our content and be sharing them. Have a nice day and still wait till the next class.